Hello and welcome everybody to today's lecture about protection in electrical power systems. Our focus now is on distance protection and especially on the basics of selectivity and grading schemes. Let's start with the selectivity. The selectivity means that if a fault is on the own line, a relay will trip. But there are little difficulties due to measuring errors. So let's see what happens if we have a fault shortly before the end of the own line, that is substation B, and what happens if this measurement is inaccurate. There may be error type 1, that is the fault is measured before its actual position. So A will quickly trip and that is okay. If we have fault error type 2, then A will not trip but in raised time, and there will be nevertheless a selective trip because relay B will not pick up, because for relay B this fault is in reverse direction and that is a no-go for a trip. So B does not trip and that is okay as well. Now let's look at the situation if we have a fault on the next line. That means the fault is behind bus bar B. So if we have error type 1, that means that the fault moves apparently towards relay A. Relay A thinks that it is its own fault and will trip. Relay B, in any case, will trip as well, and then we have two trips for one fault, and that is not selective. The situation for error type 2, that means that the fault apparently moves away from relay A, will start relay A. B will trip before anything else happens, so A will not trip. We have a trip at B and that is okay. Now let's integrate this into the solution to these selectivity problems. The solution is, as we can see, that the quick trip area is moved back towards relay A and approximately only 85% of each line are protective in quick time. And the rest, the last 15% and behind that, will be tripped in a race time. For example, in a race time of 400 milliseconds. So if we have a fault at the beginning of the line, in the middle of the line, we have a rapid trip. If we have a fault at the end of the line, we will have a selective delayed trip. If the fault is behind relay B, we have no interference because relay B will trip quickly and relay A will reset before it would reach its tripping time. So there is no interference, also not for trips further downstream. So this is okay. And now we can integrate this into a total time impedance grading scheme. So we have seen what happens for relay A for different fault positions. The same would happen for relay B and for relay C. This scheme has one more big advantage: we have integrated backup functions. Let's assume that we have a fault shortly behind relay B and that relay B does not pick up. So that means it does not pick up, there is no trip, and the fault current is going on until relay A, which sees the fault, will trip in its raised time of 400 milliseconds. The result is we have cleared the fault at a relatively short time, though it is not selectively because we trip out the whole bus bar, though only the feeder from B to C should have tripped out. But in any case, this is a backup function. Also, if a fault happens at the end of the section B to C, we can see that we raise the tripping time of A accordingly. We also can achieve a selective backup function. This was today's lecture about distance protection, basics of selectivity and grading scheme. Thank you very much.